What's up, you data friends? It's Yanis here and welcome to my channel. In this video, I'm going to show you how to use multiple LLM agents in order to query and question your SQL data. And more specifically, we are going to build this Streamlit app you see over here, where you get to specify the table name, the schema, and then you're free to ask any question on your data. Now, what's important about this app is that I don't know if you watched my previous videos that we created a similar project, which is this one, which we again point our LLM to our SQL table. The difference is that on this app, we had to limit our data as much as possible in order to feed it into our LLM and not run out of tokens, because we had this limiter over here where we could only use a specific number of our data, let's say. So we try to minimize our data as much as possible each time we ask the question. However, now we are going to use multiple LLMs in order to not have to limit our data, actually summarize our data first and then send it to the LLM in order to question it. So more specifically, just so you can understand, if I show you the structure of our solution, first we're going to have a function that pulls in the metadata from the table you specified. So that metadata is going to have information around the column names and also the description of each column. So more context for our first agent, which its job is going to be to generate the SQL query. So this first agent is going to write our query based on the question and the metadata. Then our second function is going to run that query and then return a table of results. So this is going to be a minimized data set, because I'm going to show you later on that we ask the LLM to minimize the data as much as possible. And then if it doesn't fail, it's going to move on to our third agent. But if it does fail, it's going to retry again to write that SQL query again with even less data, so we don't get the error that we run out of tokens. And then our third agent is going to take that data set newly generated. So in our example here that we asked about the top 10 fastest cars, is going to take this extracted data and attempt to answer the question in text, as you can see over here. So if I go back, and then our output is our Streamlit app. Now this is very important to understand because all LLMs have a specific target limit. But by following this approach of using multiple LLMs, multiple agents, you are able to get around that. And it's actually a very good solution on top of the previous solution, which was to use all these filters at the left-hand side to minimize our data manually, versus the first agent doing that for us, and then the second agent writing our answer. And before we start this video, let me just say that if you're passionate about data science, then please consider liking this video, subscribing to my channel, and enabling notifications for my future videos. Right, starting with the libraries we are going to need, please make sure you have installed Groq, Streamlit, and PyPy ODBC so we can connect to SQL. Next, we have some content around agents. So in the context of LLMs, agents refer to distinct roles or personas that simulate different characters or behaviors during a conversation or a task. These agents can act as individuals with their own goals. As you're going to see later on, each one of our agents is going to have a different goal. Perspectives and knowledge, let me run this, enabling multi-agent interactions where they can argue, collaborate, or exchange ideas on a given topic. And then some key concepts of agents in LLM is their role assignment, is their distinct goals and behaviors, etc., etc. You can actually read these on your own time. And then some practical applications is that we can use agents to build chatbots, creative writing, training and education, AI for collaboration, and then by designing agents with clear roles and behaviors, which is what we're going to do in our example. Now, when it comes to creating agents in AI, there is some frameworks out there like the AutoGen, LangChain, Groq AI, and Light LLM. However, personally, I don't find these very useful, these frameworks, just because I prefer the old-fashioned pipeline approach with clear steps and tasks for each agent, and then I move on to the next step. However, I'm sure that for more complex projects, probably these frameworks are going to come in handy. Right, moving on, the structure of our solution, we have explained this at the beginning. We are going to have 3 agents and 2 different functions, which we are going to go over in a bit. Our first step now is to load our SQL data. So for this, you are going to add the following information. The ODBC driver 17 for SQL Server. Make sure you use the right one depending on the SQL Server you have. Then you are going to need your server name. So in my case, let me show you this. You can get the information from here. Server name, you can see is this server name. Then I go back, my database is called card information. So if I go back again, if I cancel this, my database is card information, as you can see, and then trusted connection equals yes. And then my SQL query is basically select all from that table, and then I pass the connection, and then I'm just visualizing the first 5 rows. So if I run this to see if it works, as you can see, it returns data. So this is to test that our connection works. The next step now is to test if our API works. And we are going to use Groq API in order to call their models. They actually have a lot of models there. So if you go in their website, which is, I have all the models here. With this, paste it. You can see they have supported models. And they have Llama, they have Llama, they have more, I think, down here. Let's see, Metadata, Lava, Mixtral, etc., etc. In our case, I'm going to use, what am I using? Llama 3.1, which is developed from Meta. Before you run this, you're going to need to make sure you have an API key. If you don't have one, then you can follow this link over here, which is going to take you into your API keys. You can create a new API key. This is all for free. So make sure you create a Groq account and you create a Groq API key. You click create, you copy it, and then you paste it in our code. So that's going to be over here. Now I have actually run this already, so I'm just going to comment this out so I don't get an error. And then in order to get this code, all I did is that I think I went into their documentation, which is the chat completions over here. Scroll down, you can see they give you a very good example. You can copy this and you can paste it over here, and then you click run to see if your API key works. As you can see, it's running, it finished running. I am asking this LLM to explain the importance of fast language models. I think I should have said large over here. Anyway, fast is okay. And then you can see it returned an answer, which means that my API key works. Right, moving on now. The next thing we have to do is to start creating our agents. So we are going to break it down into step by step, and then we are going to combine everything together. So we start with our libraries at the top, then we initialize our Groq API client. So I'm just going to comment this out now because I have already run this and removed my key, but make sure you paste your key over here. Next, we have an example SQL query, which we are going to give this into our model in order to have an example of how it should write the SQL query. I'm going to show you later on. Next, we are copying and pasting our SQL database connection. Next, we are specifying our table name, which is this table over here from SQL. Let me show it to you quickly. So car info, this table over here, where is it? There we go. dbo.carinfo-web, and this is this table over here, and we also specify the schema. The reason I break these two down is because when we are actually accessing the information schema from SQL, we don't really need the schema, so I just need the table name. However, later on, when our first agent is going to generate the SQL query, I'm going to need that schema in order for the query to run. That's why I have both over here. Right, our first function, this is not actually agent 0, it's a function, is that we need to extract all the column names and metadata for the specified table with the square brackets. And this is actually important because some tables are going to have column names that are actually used in SQL. In my case, I think I had index, so I was getting a lot of errors of my SQL query not working. That's why I need the square brackets in all the column names. Right, so the metadata query is that we want to select the column name and the data type from the information schema where the table name equals and then our table name over here. So if we actually run this query, this query you see over here is going to select all the column names and also their type. This is important for our model because later on when we ask the LLM to generate an SQL query, we are only going to give it these column names to use. So it's not going to go out to hallucinate and create its own column names. Going back, cursor.execute is so we execute this SQL query, and then we also fetch all the columns and we store them into columns. Next, we wrap all the columns with square brackets. So this is what this code over here does. Actually, I moved it. Then I am printing the execute metadata for the table. So we actually see the table name and also the metadata, and then I'm creating an example query to guide the model. And this query is basically select, and then is going to select the needed column names from column metadata from the table given, where the condition which is going to be generated from our LLM, and then limit 10. And then I'm returning the column metadata and also the example SQL query. So if I comment out my key, which is fine, and then if I run this function, and then down here, I'm going to test the function. So click run. As you can see, we have metadata for table car info web. We get all the column names and their type. And then the example SQL query is this example SQL query you see over here. So if I actually copy this and test it in our SQL, I'm going to paste it down here, and then I'm going to select it and I'm going to execute it. Near limit, actually limit is wrong. Oh, is the condition? Yep, I'm not going to use the condition because we don't have the condition yet. But as you can see, this query works fine. Right, moving on, the next step now is to create this function that only extracts the SQL query from the response. And this response is actually going to be the response of our first agent, which is going to be this agent over here. So just to explain this, when we ask the LLM to construct an SQL query, it's not only going to construct the SQL query, it's actually going to provide some context too. So just to show you, I'm going to skip this for now. Let's assume we've explained this, and let's assume we've run this. So this is running this first agent. You can see over here, you can see that it generated our SQL query, yes, but it additionally gave me this SQL at the top, and it gave me some context. However, I cannot give this to SQL and run because it's going to throw an error. SQL only needs this bit over here. So what this function does now is that it filters out just the SQL query from our response, which we're going to generate later on. So it says query equals read.findAll is going to start from select. So it's going to start from select, as you can see. And then it's going to finish on the column over here, which is this column over here. And then it's going to say if queries. So if it does find a query, then take this query, remove all spaces from left and right, and also remove the right strip, which is the column at the end, which I won't need because I'm going to use this query in a subquery later on. Otherwise, if it doesn't find an SQL query, it's going to raise an error and it's going to say no valid SQL query. And we are going to use this function over here. Where is it? Yeah, there we go. So this is where we're going to use our function, which is basically going to take the response from our first agent and find only the SQL query. Right, let's explain our first agent now, which is the one that is going to generate the SQL query based on the question. So the first input that it takes is the question. The second input is the column metadata, which is actually generated from our first function. As you can see in our first function, we return the column metadata and also the example SQL query. The third parameter it takes is the table name and also the schema name. Here we construct the full table name, which is basically the schema of the table and also the table name. So this is the schema, DBO, and then the table name, which is the table name. Next, we have our prompt. And here is where we need to do some prompt engineering. We need to tune our model. So we are saying to our model, generate only one SQL query based on the question, and we're going to pass the question later on. The reason I'm saying this is because sometimes LLMs provide more than just one answer. You probably experienced this in ChatGPT. You ask something and then you get 2 or 3 responses. So I'm specifically saying I only want one SQL query based on the question. The table to use is the table over here. The columns you are going to use now is the columns we have generated from our first function, the column metadata, which is basically going to come from this function over here, which is the column metadata. The reason we do this is so that the LLM don't go off hallucinating and creating its own column names. Next, we are saying that use only the columns needed to answer the question, not all the columns. So basically, this is saying to the LLM, do not use all the columns, look at the question and only use the columns needed to answer that question. And the reason we are doing this is so we can limit the data as much as possible so we don't run out of tokens. Next, we are asking the model specifically to limit the data as much as possible and also follow TSQL syntax, so transact SQL. The reason we're doing this is because there is a lot of different SQL syntaxes out there and we only want the model to write TSQL. We also ask the model to make sure to use the correct column names as provided with square brackets. So we have actually created the square brackets. And then I'm also passing some specific information saying that invoice price and MSRP are money. So make sure you convert that into money before aggregating it. And as you can see, where is it? Over here, when we selected all the column names, MSRP is as varchar, which is characters, and invoice price is also varchar. So the LLM cannot aggregate characters. So I'm specifically saying to the LLM to convert this into a number or money so you can actually aggregate that data. And we can actually ask the LLM later on questions like, what are the total money generated by Mercedes-Benz, for example? and it's going to sum the money generated from all the Mercedes cars. If I don't say to the model that this column is money, then it won't be able to sum the varchar, the characters, so it's not going to be able to answer our question. Next, we specify the model name, and then over here we are saying to it, you are a helpful assistant, and then in role user we pass the prompt. Over here we are printing the answer, so this is only to showcase the full response, but I'm actually not going to use this in our final app. This is only to show you the full response and also the stripped down response after we use our function. We store our response into response, and in the return we run this function that only extracts the SQL query. So to test this function now, I'm actually going to run it. And then over here, I have all of our parameters. So I have our table name, I have our schema that we need, I have the column metadata and the example SQL query generated from the previous function, and I also have our question. And then on the next cell, I am running all these functions you see over here. So I'll click run. There you go, you can see here is the SQL query, and the reason this is printed, all of this, is because I have added this print over here. However, as I said, we are going to remove it, and we only going to return this function of the response, which is basically this function over here. Select the top 10 make model year horsepower from the table ordered by descent. So this is all we need, so we can actually run this in SQL. Right, moving on, the next thing we have is to fetch the data from SQL. Since we now have our SQL query, which is this SQL query, we can actually test it. Let's see if this works in SQL. So I just copied it, and then I'm going to paste it down here. There we go. And then I'm going to try and run it. Okay, ignore the syntax, it's very wrong, but the query works fine. These are actually the fastest cars based on horsepower, which is also nice because our LLM generated the correct SQL query. So what this function does is that it executes this SQL query that the LLM generated. So we pass the SQL query in the function. This is executing the SQL query. It's storing the columns into columns. It's storing the data into results. It's creating a new data frame with the results from here, and then columns equals columns, and then it returns our data frame. So if we actually run this function now to test it, you can see over here that we are running our first agent, which is this agent over here, and we are storing the results into SQL query, and then we are running this function, and then we are passing the SQL query. And let's run it. There we go, you can see we got exactly the same data frame as we have in SQL over here. The next step now is to feed this new data frame now into our next agent and ask the agent to use this as input to answer the same question we have asked before. So it's always the same question, but it's being used by different agents. So we are creating this agent called answer question from data frame, and we are passing the question and also this new data frame generated. The first thing we do is that we have to convert this data frame, which is relational data, into text, into JSON actually, so the LLM can understand the data. So we run this df.toJSON and then orient equals records, and we save it into df_JSON. And then we define our prompt, which is basically based on the following data, answer this question. And then the question is going to be the question we have over here. And then the data is going to be this data over here, which is basically the result of our previous agent converted into JSON format. We are using the same model, we are using the same system as before. You are a helpful assistant. Into role user, we are passing the prompt, which is going to be this prompt over here. Model equals model name, that's fine. We store the response into response, and then we return the response. So if we run this second agent, and then we test it down here. First, we need to run fetch answer from a database, which is basically this function we created above. And then we pass it the SQL query we have created above. We specify the question, which is what are the top 10 fastest horsepower cars in our data and their details. And then we are running this function now, and we pass the question, which is this question, and then our data frame, which is this data frame. And as you can see, our second agent now used the first agent output in order to generate this new text. The next step now is to run everything together. So over here, I have basically copied and pasted, let me comment this out, so make sure it works. I have copied and pasted all of the functions I have shown you above. I think the only difference is that I have created this handle question function, which I'm basically having all of the variables and functions in a nice order. So it makes more sense. And then I click run, and then we can see, oh, we got an error actually. Sometimes the LLM doesn't always generate the correct SQL query. This is why later on, I'm going to show you how to rerun and rerun again, just to make sure we get it right. So let's try one more. I haven't changed nothing, and you can see this time it worked. You can see we have our first function, which is extracting the metadata. We are printing the fetch data frame, and down here we also have the answer to our question. Right, our next step now is to create our Streamlit app, and I'm also going to show you how to add the reruns to avoid the failure we just had above here. Right, starting with the libraries we need, make sure you have all these libraries. Make sure you paste your API key over here. Down here, we are setting the Streamlit layout into white. So if we check our Streamlit, you can see it's white. Then we are creating the connection to our database, and we are storing it into this function called connect_database. It is exactly the same data as above. Next, I am adding this AI pick one as it's not the sidebar. This is the main picture. So I'm just going to say main pick, which is basically this picture you see over here at the top. Next, I am adding a sidebar with a header called filters. So this is the sidebar you see on the left-hand side. Next, I have an input in the sidebar. So st.sidebar text input. And over here, I need the table name. And as a default, I have the table name we have been using all this time. So if you check over here, we have table name, and we also have the schema I'm going to show you in the code. Now, the reason I have this is because this project we are running, we can actually use it for any other tables we have in our database, because we haven't used specific filters like we have used before from that table alone. We have actually used multiple agents in order to look into our data, and they're going to try and filter our data as much as possible so we don't run out of tokens. So this project is very useful if you actually learn how to do this. Right, we also have the schema input, which we have just shown, and we also add a picture on the sidebar. So this is actually, this header should have been here, and then the header we had here should have been down here. So this is the sidebar pic. Anyway, this picture is basically this picture you see over here. Moving on, we are setting up two columns for our app. So column left is going to be this left-hand side in our app, and then column right is going to be this right-hand side in our app. Next, we start by creating our functions. So our first function called extract table metadata is exactly the same function as we have explained above. Next, we have our function to generate the SQL query. Again, we have explained this function before. All you have to do is copy and paste it down here. Next, we have the function that extracts only the SQL query from the response. Next, we have the function that runs this new SQL query generated from our first agent into the database and stores the results in the data frame over here. Next, we have our next agent, which is basically looking at this new data and is attempting to answer the same question given at the top. And down here is where we are going to add the retries. We're going to retry 3 times because, as you can see, sometimes the LLM does not get it right from the first time. So this is why I am adding these reruns. So I'm creating this function called run with retries. I pass the question and I also pass the number of retries, which is 3 times. I start by setting success to false, attempt to 0, results df none, and also answer equals none. Now, while attempt is less than the retries, so attempt is 0, retries is 3, and not success, because if it's successful, we are going to change this success to true, as you can see down here, then we start our first attempt. And in our attempt, all we are doing is that we start running all those functions we created above. We start by extracting table metadata, then we generate our SQL query, then we add some subheaders, and we also paste the code. So this st.code SQL is so that we can see the SQL code generated, which is what you see over here in our first attempt and also in our second attempt, which actually worked. Now I have added this just to be able to troubleshoot in case I get wrong SQL queries. However, if you're taking this to business people, they don't need to see the SQL queries generated, so you can actually comment this out. Next, I am running the fetch answer from database, which is basically running our SQL in our database. And then I am running our second agent, which is basically answering the question based on this new result df. If this is successful, then it's going to turn this into true and it's going to stop. Otherwise, it's going to throw an exception, it's going to print the error, it's going to pause for a second, and it's going to retry again. Now, if it's successful, you can see that we are going to return the result data frame and the answer, which is basically the result data frame you see over here, and the answer, which is this answer over here. If not, it's going to retry 2 more times, and then I never got 3 errors in a row, but it's possible. So maybe you want to add more retries, or you want to go back into your code and change a few stuff based on the errors you get. Right, after creating this function now, we are going to start printing stuff in our Streamlit app, which is basically this piece of code down here. On the left column now, we are printing the ask a question, which is basically this ask question over here. And then we are creating this text input, enter your question, and then the default question is this question you see over here. You can actually change the default question. I am adding a button, which is basically this submit over here. And then if we click this button, we are going to run this function we have created above here, which is this one, run with retries, which returns the df and the answer. And I'm going to store df and answer over here. If the df is not known and answer is not known, so basically if we do have a df and an answer, I actually want to print the answer, and I want to print the data frame on the right hand side. So my data frame over here is actually going over here, where I have st.header extracted data, which is this bit over here, and this is my df you see on the right hand side over here. Right, the next step now is that we need to deploy our Streamlit app we have just created, and for this we are going to use Visual Studio Code. To do this, you need to create a new .py file, so a Python file. You will need to copy and paste your code we have just created over here. So copy, and then I'm going to paste it here. I'm going to name this as SQL underscore agents, and then v2, because I think I have a v1, v2, click rename, make sure you save the file, save Python file, and then make sure you also have your key over here. Next, I'm going to close this. I'm going to go and get that file and then paste it in the location I want it to be, which is this one over here, copy, and then I'm going to paste it over here, and I'm going to open it using Visual Studio Code. Now, I already have this Visual Studio Code open, so I'm going to open our new file, which is this one over here. I'm going to pause the video to paste my API key at the top. There we go. I have pasted my API key at the top. And now in order to run this, we need to create a new command prompt. And we need to run Streamlit run and then the name of our file .py. So I'm going to paste this here, click run, and this should open our new Streamlit app in a new window, as you can see over here. There we go. So I'm going to move this over here, and then I'm going to click submit in order to test it. You can see it's running. We have our default table name, our default schema. We got a failure on the first attempt, connection error, connection error, connection error. Right. The reason I got connection errors is because I didn't click save when I pasted my API key. So I'm going to do file, save. So now I don't have anything. And then I'm going to go back into our app. I'm going to click rerun. Now we have one API key. And now I need to run the question again. There we go. This is our first attempt. Oh, it worked from the first attempt. So we have our SQL query, and then we have our answer. This is actually amazing because I haven't filtered the data at all, and I did not get an error of running out of tokens. Versus the previous video that we had to limit the data so much using our filters and the number of rows in order to get it to work. Right, let's try and test a few other questions. Let's do describe our data. So this is actually a big one because I'm not asking anything that's going to limit the data, and it's very open-ended question. So let's see if this works. We got an error, attempt 1, attempt 2, attempt 3. Okay, 3 failed attempts. Let's try again. See if it's going to try anything different. Because LLMs always have different responses. Oh, there we go. We got something that worked. So we got an error on the first attempt, second attempt, and then on the third attempt, it actually managed to generate an answer. And it says, the data appears to be a collection of JSON objects where each object represents a car make with its corresponding average manufacturer, suggested retail price, which is MSRP, and average invoice price. And then we also get a few more insights down here. This is very good because I've just asked the LLM to summarize all of our data, and then it managed to limit the data on its own and create a summary. Let's test something that has aggregations. So it has to use aggregated functions. Let's do what is the average MSRP, which is like the retail price of the cars per make. Make is the manufacturer, which is this over here. Let's see if this works. So error on the first attempt, and then it worked on the second attempt. And it says, to calculate the average MSRP per make, we need to divide the sum of the MSRP by the number of makes. So it actually says a different thing here, but the calculation is actually correct. I think this is wrong, and this calculation is correct. It doesn't matter though, because it worked, which is great. Let's try something else. Let's do what is the total maybe, and let's see if the sum is correct. Total MSRP per make. We should actually add a condition. Let's do for 2024. Let's try this. What is the total MSRP? Maybe we need to specify sum. Oh, there we go. The third attempt, did it work? No, we got an error. Let's do what is the sum of MSRP per make for 2024. Okay, we got errors for all attempts. Let's try again. maybe I need to add more attempts because they get the SQL query correct. There we go, the third one worked. So to find the sum of MSRP per meg for 2024, we can calculate it by, and then it explains how we calculated it. But you can see it's not bad considering we are giving the LLM all the data and we are not filtering it at all. So you can actually work a bit more on this to tune the model a bit more, and you're going to have a very good performing model that is open to literally any table you have in your database. Right, so this is it for this video. Very interesting, cool functionality. I think you guys should definitely learn how to do this. I hope you've enjoyed this video and you've gained enough value out of this video. If you feel like you did, then please click that like button, subscribe to my channel, and enable notifications for my future videos. If you have any questions or thoughts, please let me know in the comments below. Otherwise, thank you very much for watching, and I'm going to see you in the next video.